Well, good day, then. In this video we are going to solve exercise 3.1 from the book Fundamentals of the Psychoelectric Circuit. Well, in this exercise we are asked to determine the current Ix in the circuit shown in figure 350 by applying annual analysis. So, I don't think, to determine this current but using analysis not to give. So, what I'm going to do is locate myself here at this point and I'm going to call it voltage V. We need the voltage at that point to determine the current. Now, the first thing to do in these circuits is to analyze. Do a visual inspection to analyze the flow of the currents. Let's remember that the Kirchhoff current law tells me that all the currents that enter are equal to those that leave. That is, if I here in a node somewhere the current called I1 enters, it is assumed that the currents enter through that node and will exit through another side. It is assumed that the current I2 can come out here and the current I3 can come out here, or two currents can enter and leave. Well, using from the beginning and doing a visual analysis, I observed that a current is going to enter here. I give you the direction because I am seeing the polarity of the voltage. The 9 volts is indicating that if positive is up and if negative is down, therefore it generates a voltage in that direction. The current and another current is supposed to come in here. After us we have this the currents, since previously they can be identified with a name. I'm going to call it I1 and I'm going to call I2 these two connects that enter at this point, and the Ix is going to come out, so that principle tells me that I'm going to put an equal sign here and I'm going to say on one side of the sign of the equal sign of equality, the currents that enter will go, those that leave will go to the other side. So I know that what comes in at that point is I1 plus I2. I1 plus I2. And the Ix comes out. Well, now the current that enters here, the I1. Obviously, according to Ohm's law, this voltage is equal to current times resistance. So, we have to calculate the current as such over resistance. Now, here, I observe that at this point there are 9 volts, since there is a tension there, or I don't know what it's called. But if I read that current address, if I establish that address, it means that the new hotel is bigger than this B that I don't know yet. If not, when we do the analysis, the current will be negative. That for the moment we are going to assume that the voltage be 9 volts greater than B1. So I know that the current I1, which we are going to find here, is 9 volts minus a voltage versus that I had already called envelope. Remember that everything above is voltage, over the resistance that would be 1 and low. This is going to be plus a current I2 that I already established. That current I2 and what you have right. That is, it is 26 volts here greater minus the voltage. Here that is called B, over the resistance of 4, and then K means times 10 to 3, that is, times 1000. All of that is the same. Remember that this here is 41. This here is 42. Fluctuate for Ix and the X can see the attention over the 2 kilometers. Good. So, having these equations, the dialogue he wants to ask me is to evaluate them. For example, here I am left with 9. over K minus the pension over 1K plus 6 over 4K minus the care B over 4K equals B over 2 kilometers. Now what we are going to do, leave the variables B on one side and the constants on the other side. I come to this point and say, ready, I'm going to pass everything that has the variable B to the other side of the equal. So, I'm going to place here, B over 2K. This one that has a negative sign passes with a positive sign of about K minus a more. This is less pass another next deposit more than about 4K. Plus 6 envelopes. To follow the equations. Now, if I enter this into the calculator, a half plus 1 plus a quarter. What's more, 7 over 4 K and B equal to what this is, which would be 21 over the K. If you want, you can check it yourself with the calculator and you will see that the result is correct. So I pass this there to multiply and I pass this to divide. It tells me that the voltage at that point is 6 volts. Now, what it tells me here is that at this point there is a voltage of 6 volts. So, if there is a voltage of 6 volts here, we can now determine the current. And the current Ix, instead of what it was, is the voltage V over 2K. So, what they are asking us for was K the current and X. Except the current Yx is equal to 2 carry over the 2K resistor. Therefore, it would be 6 volts over 2 kilo ohms, and this is going to give me 0.003 amps and 3000 amps. So, Ix is equal 3. This is the circular current through the 2K resistance. K